In the previous video, I showed you an inefficient way of determining if this series will converge or if it will diverge. Remember, from here we used the root test, and then the root test gave us this, and then it was this multiplying with this. That then gave us this, and then it really boils down to us trying to evaluate this. And I showed you an inefficient way of doing it. So now for a more efficient way. So whenever you see this, if you look at this is very similar to this. And remember, in the past I've asked you to ingrain this in your mind. So you should, the minute you see this, then you should think about the number e. So in general, if you have, let's say, a number a here, then it would be e to the power of a. And I've asked you to ingrain this in your mind. So memorize this if you can. Okay. Well, if you look at this here, this is very similar to this. The only difference is that here you've got a minus, but here you've got a plus. But don't forget, you can always push the minus into here. So it's like this. You can always push the minus into here. This then becomes a plus. So now you've got your plus, and this a here happens to be -1. So even though it's a minus, you can always push it in there. So it becomes e to the power -1. So this is your a here. Well, just bear that in mind. And the other difference is here you've got n squared, here you've got n, and then here you've got n squared, here you've got n. But let's address this. Hang on. So going back from a long time ago, we've seen this, the limit of sine of x over x. If I were to give you this, hang on, if I were to give you limit x squared sine of x as x heads towards 0, you would draw a graph of x squared. And then this thing here, sine of x is just going to do something like this. So the limit of this, as x heads towards 0, well, it has no choice but to head. So the limit of this is 0. Now when you have, you can visualize this as this thing here. So you would draw your graph, or your reciprocal graph. That will look like this. Hang on, let me draw the negative version. So this thing here, sine, will look something like this. But for some strange reason, it crosses over at 1. Now it crosses over at 1. Dead on 0 is undefined. So it should be this. Dead on 0 is undefined. Dead on 0 is undefined, but for some strange reason, the limit is 1. And we've seen this in the past. And we use the squeeze theorem to actually prove this. We have seen this before. Now, if I were to give you this, let's say 7. But by the way, let me just try and remind you what we were trying to do. Here we've got n squared. Here we've got n squared. But here we've got n, and here we've got n. Just bear that in mind, okay? So hang on. So if I were to give you this, what is the limit of this thing as x heads towards infinity? Here you would times top and bottom by 7. So that will then give you 7 here, and then 7x at the bottom. Now this thing here is exactly the same as this. Hang on, this here is a constant, so let's take it out here. So it will be hang on, oops, hang on, bear with me. Oops, hang on, bear with me. So this 7's a constant, so you can take the 7 out. Oops, bear with me. So this 7's a constant, so you can take it out. So it becomes this, and then now it just boils down to us evaluating this. Now you can see that this heads towards 0 at exactly the same rate as this. So here you can actually use this, because here you've got 7. Here you've got 7x. And 7x. So that's very similar to these two. They're both heading towards 0 at the same rate. This, even though this is x, the bubble here is heading towards 0 at the same rate as this thing here. So this is very similar to this. This is heading towards 0. It is heading towards 0. But then if you look at this is also heading towards 0. This is also heading towards 0 at the same rate. So you can actually imagine this scenario as being this scenario. So you can conclude that this here is 1. So earlier we had 7 here. So the limit here will be 7, because you would times top and bottom. You would times top and bottom here by 7. That would then give you this. and then you move the 7 out here. That will then give you this. So now this scenario here is so similar to this scenario. So you can say that the limit of this is 1. Now going back to where we were before, we've got n here, n squared here, n squared here. Even so imagine this as being a bubble. Even if you have something like this, even if you have let's say 7n to the power 3, 7n to the power 3. If this bubble, you see, this is very similar to this. If you look at this thing here, if you look at this thing here is heading towards infinity. This thing here is heading towards infinity at the same rate. Now, even if you have 7n to the power 3, 7n to the power 3, as n heads towards infinity, this thing here is definitely heading towards infinity. It's getting bigger and bigger and bigger. This thing here is also getting bigger and bigger and bigger. But the thing is, these two are heading towards infinity at the same rate. So you can consider this scenario as being the same as this scenario. Because here you've got a bubble here and a bubble here. This bubble here is heading towards infinity at the same rate as this bubble. So this thing here is the same as this. So what I'm trying to say here is that this scenario here is exactly the same as this scenario here. Because this is heading towards infinity, because n is heading towards infinity. This is also heading towards infinity. They're both heading towards infinity at the same rate. So that's the same as this, heading towards infinity. Well, these two are heading towards infinity at the same rate. Heading towards infinity at the same rate. Even if you have, I don't know, 5x to the power of 10 plus 3, 5x to the power of 10 plus 3. This is going to head towards infinity. This is going to head towards infinity at the same rate. Therefore, you can consider this scenario as being the same as this. Now, let's go back to the very start of the very start. We were trying to determine if this would converge or if this would diverge. Using the root test gave us this, and then this thing here becomes this, and then really it boils down to us evaluating this. It really boils down to us evaluating this. Well, imagine this as being in a bubble here. So now push this minus 1. So imagine this as being a bubble. Push this minus into here. So now it becomes this minus and then a plus. So now this scenario here is very similar to this one here. You've got your a here. So this is our a. Our a is actually minus 1. You see, even though we've got n squared here, this thing here is heading towards infinity at the same rate as this. So we can consider this as this. So well, anyway, this whole thing here. So you can imagine this as being n squared here, n squared. So this is really this is acting in exactly the same way as this. This is heading towards infinity, heading towards infinity. This is heading towards infinity, heading towards infinity. So you can conclude that this whole thing here is actually e to the power of whatever this thing is, this a here, which is minus 1. Well, anyway, this whole thing here becomes this. So now the value that we were trying to find, this value here, is actually less than 1. Therefore, we can conclude that this series will converge. Okay.